Okay, in this video we'll be learning factoring by grouping. Okay, and as it says in its topic, factoring by grouping means that they're being grouped because something must be common with them. All right, so those are ones which we will be looking at for right now. So let's see. When a polynomial has 4 or more terms, we see if we can factor it by rearranging terms in groups that have common factors. This method is called factoring by grouping. So this is what we will be doing. So let me give you pointers on factoring by grouping. Okay, one, group, and this is what you will be doing. Will group the terms of the polynomial. And why we mean the polynomial? Because the polynomial may have a lot of them all over the place. Okay, so that the first two terms have a common factor, and the last two terms have a common factor. So notice the first two terms and the last two terms need to have something common with respect to their position that they are holding. So the next point will be factor out, and these are actually the steps that I'm giving you. Factor out the common factor from each group. Because you have grouped the terms now, they have something common, so you will factor out the common term that is within that particular group. For right now, I'm giving it in the words, the steps, and then we will be working some of them. Then the last part will be factor out the resulting common binomial. Binomial is coming back again. Binomial factor. Okay, if there is no common binomial, very important. Okay, binomial factor, regroup the terms of the polynomial and repeat step 2. So we'll repeat that if there's nothing common, step 2, and step 3. So those are 3 main steps that you need to do whenever you're factoring by grouping. Okay, so let's start. I'm gonna start with the simplest one. Consider if I give you a problem like this. I say example. Okay, and I say factor 2c minus 2d plus cd minus d squared. Okay, now we will be factoring out the common term, and it says group terms of the polynomial so that the first two terms have a common factor. So our strategy here will be is that we need to know that there is no common factor of all 4 terms. There's nothing common in all of them. Okay, so that's one good observation. Then we will factor out a common factor from the first 2 terms. What's common here? If you notice that the term 2 or the value 2 is common here, then you're going in the right path. Okay, and a common factor from the last 2 terms, what do they have both in common? They both have these, the letter D. Okay, next part, why are we going to do it that way? Because it is often this that will produce a common binomial factor that can be factored out. So our solution now, let's see. Since 2 is a common factor, if you notice here, since 2 is a common factor of the first 2 terms, and d is a common factor of this last two terms, we now have, and let me write it here, let me do the working. So 2c minus 2d plus cd minus d squared equals, since both of them have the common term 2, we take out the 2 here and we put open bracket, and when we say 2c divided by 2, we end up with c. When we say 2d divided by 2, we end up with d. Notice carefully, the sign remains there, okay? So try to use a positive value there. And then, what do they both have in common? D. You will keep the sign of the first common term, which in this case is positive. So you put plus D, okay? Open bracket. CD divided by D will give us C. D squared divided by D will give us D, okay? And if you were to reverse this process, you would get back the same value here. Now, notice what is in red. Since both of them have CD combined as a common term, and if we were to close them off, we see CD as common. If we take them out, you notice what we have. We have 2 plus D. Okay? So therefore, let's take the common term first. I put there C minus D, open close bracket, and then bring down open bracket, 2 plus D. And so we have factored out the C minus D. So let me give you a few notes on this piece here. Factor out the 2 from, so here what we did, factor out the 2 from 2C minus 2D, and we factor out the D from CD minus D squared. And then here we factor out C minus D, and those are the steps for us to do that. We can check this by multiplying. Now, if you want to check if your answer is correct, you can go ahead and multiply these terms, okay? Say for example, if we rearrange it, we want to prove that this is the same thing, because this needs to give us back this same polynomial here. All right, so we could check by, so let's do the checking. So check, okay? So if we take C minus D, open close bracket, 2 plus D close bracket equals, we're going to take C times 2 plus D minus D, 2 plus D. 2 times C, 2C. C times D, CD. Negative D times 2, that would then give us a negative, was that a 2 that we have here? Yes, a 2. So we would have negative 2D. So then we will have a negative 2D. Negative D times positive D will give us a negative D squared. Now, they look almost alike. The only difference is that, well, they're actually the same. The only difference is that you might notice here you don't have the negative 2D in the same position, okay? That is no problem, because 1 plus 2 is the same thing as 2 plus 1, okay? So long as both of them are in the same sign. So if we were to say CD minus 2D plus CD minus D squared, we end up back with the same value that we started with, okay? So that's not that difficult to us to be working with. Okay, so let's try our next example. So we're going to go with the next example. Our next example is as follows. It says factor, okay, and I have 7x minus 7y plus xy minus y squared. Look at the first two terms. What do they both have in common? 7. Excellent. So put 7 outside, and it says 7x divided by 7. Well, the 7's will cancel, giving us x. And you put the negative sign here, and 7y divided by 7, that gives us y. Close bracket. Here, what do they both have in common? Y's. Excellent. We keep the sign of the first term here, so we put plus y, open bracket. Xy divided by y, that will give us simply x. And then bring down that sign, and we have y squared divided by y, that gives us y. Okay, now we haven't finished yet, we're still halfway. What do they both have in common? X minus y. So therefore we put x minus y, open close bracket, 7 plus y, 7 plus y, and that's our solution there. Okay, now just in case if you're wondering how I get x minus y, how come this becomes this? Well, let me do the work on the side. By this time you should be able to do this type of work in your head, but to ensure, this is what happens. You actually have 7x divided by 7 minus 7y divided by 7. Anything divided by itself is always equals to 1. Excellent. So they cancel, leaving us x minus y. The same thing here, we have xy over y minus y squared over y. Cancel, we have a single y, and that's how we get that term there. Okay, so again, just use step by step and you should have no problem whatsoever. Let's go to some more problems now. Notice here we have the square on the second or on the third or the fourth term as the one before. Now we're going to start to move those values in other parts of the problem. So if I give you now factor x squared y minus ax minus xy plus a. Our strategy here is that we need to know that there is no common factor of all four terms. There's nothing common in all of them. Okay, then we will factor out the common factor from the first two terms. So let's factor out something common here and factor out something in the second two terms. Okay, why? Because this will often produce a common binomial, which we have done. Okay, and then we come to our solution. Since x is a common factor of the first two terms here, okay, since x is a common factor, this is what happens. Let me do the steps in red. X common, so we bring down the x outside, and we now say x squared divided by x squared y divided by x will give us xy. Bring down the negative, and then ax divided by x gives us a, close bracket. Now look at the third and fourth term, negative xy plus a. So we have factored out x, from the x squared y minus ax. If we factor negative 1 from this one here and plus a common binomial factor appears. All right, now what does that mean? Let's look at it this way. I'm going to factor out the negative 1 which is in front here. I'm going to put a bracket everything inside. So therefore this is what happens. I put a negative 1 because they don't have nothing in common, so I put negative 1, and negative xy divided by a negative 1, a positive xy. Positive a divided by a negative 1, negative a. Now doesn't this look beautiful? Look at it, they look the same. They're the same thing, xy minus a. So both of them have xy minus a as a common factor now. Now, because xy minus a is common in both of them, this is what we do. We put xy minus a, open close bracket, open bracket, x minus 1, and we finish there. There's nothing to say that these terms need to be a single letter or a single number. They can be 2 letters, 3 letters, or in fact it could be an x to a power. Okay, so that should not be a problem. All right, now a caution: when factoring the expressions in the previous two terms that we saw, don't think that let me write it down. So this is a caution that I need to give you based on just two examples that I have shown you just now. Don't think, okay, and I don't want you to think, okay, don't think that 2c minus d plus d c minus d or xy minus a minus xy minus a are in the factored form. They're not in the factored form. Okay? For an expression to be in the factored form, the results need to be a product. What does that mean? This is a product. This is not the factored form. This is still in between. Okay, so this is the factored form because you cannot go any further than this. This needs to be joined by multiplication. All right, so that's just a warning. All right, let's go to our next other examples. I give you factor 10k plus 10m minus 2km minus 2m squared. Okay, our strategy here is that since all four terms have a common factor of 2, notice that everyone have a common factor of 2. All right, compared to the previous one, not all of the terms had something in common. In this case, they all have a common factor of 2. They could have had a common factor of 3 or 4 or 5. The point is that they have something in common, or all of them could have had k. That's a common factor also. We will factor out first the 2 from everyone. Then we will factor out the resulting polynomial by grouping. Why? Because factoring out the GCF first makes the factoring process much easier. These are big terms. If you can reduce them, you can go ahead and reduce them. So let's factor out the GCF. So the first step will be 2 open bracket 10 divided by 2 5k, 10m divided by 2 plus 5m, negative 2km divided by 2 km, negative 2m squared divided by 2 m squared. We have finished first of all factoring out the 2, or we have factored out the GCF. So here we factor out the GCF, the greatest common factor in all of the terms. Now forget about the bracket, just work with what is inside of the bracket, right? So let's come down here, bring down the 2. We're not going to touch the 2 right now, it's going to work inside. We're going to factor out the 5 in the first two terms because they both have a 5. So we put here 5, and let me use red now. 5k divided by 5k, 5m divided by 5 will give me m, close bracket, minus, what do they both have in common? M. Excellent. So I pull out an m. Now remember, I told you to keep the sign of the first term here with the last two terms, so that's a negative. Now here you need to be careful now. Negative km divided by a negative m, well, a negative divided by a negative will make it a positive k. A negative m squared divided by a negative m, well, the negative and negative will make it a positive. M squared divided by m, m squared divided by m will give me simply m, and then we close the big bracket now. Now the inside part is what we need to factorize next. So we bring down the 2, open bracket, combine them, k plus m, close bracket, and we put 5 minus m. You don't have to be using different color pen, all right? I'm just using so that you can see how are those letters coming together. Now at this point we could leave it this way, it's still correct, but it looks more professional if you get rid of this outside bracket because this is already multiplication. So our final result will then be 2k plus m, open close bracket, 5 minus m, close bracket. So we end up with that value there. So this is our final solution. Remember the caution that I gave you. Don't think that this is the final product. For it to be factored out, they need to be a product. Okay, let's try our next one. Factor negative 4t minus 4s minus 4tz minus 4sz. Okay, first of all, what do they all have in common, if any? Well, they all have the value 4, so we can pull out the 4 right away if you want. Okay, and since all of them have a negative 4, why not take out the negative also? So let's go ahead and take out the negative. So it becomes negative 4 open bracket. Negative divided by negative will make it a positive, so we end up with t. Here will then be s. Here will then be t z plus, and here will be s z close bracket. Okay, now if you notice here, they don't have nothing in common. Okay, only these ones here have the z and the s. So you could bring this side, you could bring this side. That's up to you. So notice here, these two terms don't have nothing in common except the value 1. That could still work. Okay, but let's see if this t is present in any one of them. Yes, it's present in this. Is this s present in any one of them? Yes, it is present with this one. So therefore, let's combine them. So we end up with now t plus tz plus s sz close bracket. Okay, equals now negative 4. What do they both have in common? T. Put t there, open bracket. So t divided by t, 1. Tz divided by t will give me z, close bracket. What do they both have in common? S. So we put s divided by s, 1. Sz divided by s, we get z, close bracket. Now, they both have the common term 1 plus z, so we could go to the other step. I put negative 4 open bracket 1 plus z open close bracket t plus s close bracket equals now negative 4 open bracket 1 plus z open bracket t plus s close bracket, and then this is the final value. This is still correct, but I would prefer you to go to this step here so that you get rid of at least one of the set brackets. Okay, so this is your final solution for that one there. This is simply factoring by grouping. Okay, and so we stop at this point for this topic.